And welcome to the Daily Space Weather Show. The first coronal mass ejection that we forecasted arrived exactly when expected. There are more on the way. In fact, a second has already shown up. These have been weak impacts. The one from this morning that you're seeing there on the first imagery that we're showing looks like a halo eruption, right? Is that one on the way? We'll tell you all about it and lots more here at the Smash News Network, least busted name in news. We'll get to coronagraphs a little bit later. First, a 24-hour video showing a highly inactive sun here. Sunspot number dropping down to like 70 sunspots. Also a dip in the radio flux. It is very weak solar activity. A prime example of how you can see not a lot going on the closest star, and yet space weather arriving at Earth. Remember, folks, you don't need to see solar flares or even sunspots to see coronal mass ejections. Filaments are known to eject from the solar corona without any of those features present. By the way, if you enjoy the content, don't forget to press the like button. Yeah, the like button. And maybe even tell your friends and foes about the channel. I don't know. You know, it is the most comprehensive daily space weather content in the known universe. You'll also find, as you can see here, the most detailed solar imagery you'll find anywhere. As we empower our viewers to understand facts about space. Now, I came from the realm of cosmology. I almost majored in cosmology back in the mid-1990s upon realizing there's a huge hole in that field of science because of heliophysics. And I'm not going to get into it in depth today on today's daily space weather video, but let's just say there are some issues with cosmology. Have you noticed how practically every interesting observation in cosmology just refutes the concordance model of stellar evolution? We don't know how this could be. We don't know how that could be. We don't know how the other could be. There's a reason for that, folks. And yeah, so anyway, many times in science we end up with answers to questions not asked, which is what's occurred. And please let me stop talking about this by pressing the like button. If you're new to the channel, press the subscribe button. Do yourself a favor and get the world's most comprehensive daily space weather delivered directly to your YouTube subscription feed. And if you're not seeing the videos in your subscription feed, we've got solutions for that too. However, it is on you to utilize those solutions. Other solutions include our paid affiliates and sponsors. So, our first paid affiliate / sponsor link is to our Redbubble shop, where we sell our merch. Today's featured product is the Smash News Network least busted name in news logo. It features the YouTube URL. Let us know in the comments if you think we ought to rebrand the channel entirely to just SNN, the Smash News Network least busted name in news. Of course, we only cover very specific types of things on the channel. Now, this design was requested by one of our viewers. We do requests as far as the merch goes. If you've got a merch item, perhaps let us know about it. So there's today's featured product, linked below the video in the Redbubble shop, along with 36 other designs on dozens and dozens of different types of products. Thanks to everybody who's picked up merch and helped advertise the channel. Another featured product is, again, this is another paid affiliate / sponsor link, folks. We do receive a tiny commission on sales from the Amazon storefront, amazon.com/shop/smashomash. Today's featured product there is our electromagnetic radiation reflecting bucket hat. Yeah, you can also find eclipse glasses there if you don't have a set of those. Multiple different choices there for eclipse glasses. The Amazon shop, also linked below this video. Help out the channel that way, perhaps increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. Another way to support the channel is via the Hemp Lucid shop. Support your sleep, immune, and stress response with massive savings on Sleep Immune and Stress Stacks. Save $15 on any of those, or even more if you go for the full stack package. CBD lip balms now back in stock. Lavender body balm now in stock as well. And there are some new flavors with the mushroom gummies on which you can also save some cash. Mushroom gummies are $5 off. They've got blueberry flavored mushroom gummies now. So check it out. The most popular product is the CBD water-soluble tinctures. Hemp Lucid link below the video as well. You can also find these links on the homepage at smashomash.com. So welcome to the Neo Renaissance. We launched this massive web ring back in February of 2019. When a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the videos, maybe you can hire the Smash Team. No, you certainly can hire the Smash Team because there's a link right there. And that is the best way to support the channel. By becoming a member of the Smash Team, you'll get additional content. It's kind of like a paywall. Sort of like Patreon, just a little bit better. Launched officially back in October of 2021. There's a bronze level. There's a silver level. There's a gold level. There's even a gold annual paid-up subscription. Smashomash.com/Smash Team, the official subscription services site of the Smash News Network, least busted name in news. And let's get to some more solar imagery for you here. Here is the SDO continuum for October 17th and October 18th to date. Again, a further decline in the sunspot number here. Those groups have been rather stable, however, over the past 24 hours, so looks like things will hold steady here for the next update for sunspots. There is the SDO magnetogram for that same period of time. That's, again, October 17th and October 18th to date. And let's take a brief look at what's going on planet Earth. You can't be spaced out all the time, folks. Sometimes you have to see what's going on terrestrially. Well, Bezimiany continues to explode, produces a 17,000-foot ash plume over central Kamchatka. Sakurajima producing a 10,000-foot ash plume, a slight downtick since yesterday. Sakurajima still exploding. Flight level 100. Flight level 080 over Subanose-jima as it explodes. Mount Mayan effusing some new real estate there on Luzon Island, Philippines. Also, incandescent block and ash flows continue to emanate from the Summit Lava Dome as viscous lava material. Also, block dome avalanches, pyroclastic density currents usually form ash plumes, phoenix clouds, tower. So lots going on there at Mayan. Mount Ibu exploding. Flight level 070 to 7,000-foot ash plume over Halmahera. Rupahu has the crater lake cooling off. So, cooling trends there on the North Island of New Zealand. However, these do not affect the long-term heating or cooling trends. Key gas indicator suggests the temperature of the gas deeper in the magmatic system has increased, while not currently affecting the temperature of the lake. So discolored water, yellow sulfur slicks on the lake surface indicate water and gas flows into the lake from below. So interesting stuff going on there at Rupahu, the North Island of New Zealand. Gas is still flowing through the volcano there. Popocatépetl in central Mexico exploding, flight level 190. Nevado de Ruiz exploding in Colombia, flight level 220. Sangay in Ecuador exploding, flight level 220. Revenador exploding, flight level 190, and intermittent emissions from Sabancaya are an important reminder to not pole vault the caldera. Don't pole vault the caldera, folks. If you're going on a volcanic vacation, leave the vault pole at home. Next, earthquakes. And it's been pretty calm, seismically speaking, in the past 24 hours. There are the past 90 days. Only 3 7+ magnitude quakes over the past 90 days. That's a notable feature of statistical earthquake activity, right? Here are the quakes of a 5 or greater magnitude over the past 24 hours, starting with a 5.6 at the Loyalty Islands. North of New Zealand there, that 5.6 occurred at 13:40 Universal Time yesterday afternoon. And another Iranian quake, a 5.4, happened there at Iran. That was at 1626 yesterday, Universal Time. After that, Kermadec Islands at 2152 had a 5.2 magnitude quake. And Guam had a 5.2. That was at 8:11 Universal Time this morning. Pretty seismically calm over the past 24 hours. And heading back to space, here we've got some additional images here. Here's SDO 211 plus 171 angstroms. Great wavelengths to show the lower quiet corona as well as the extended corona, coronal holes, and active regions. Here's a little closer view in those wavelengths. Another 24-hour video from SDO. And let's subtract the 211 angstroms. There's 171 by itself. The house favorite wavelength. And again, there was a coronal mass ejection from this morning. It started to appear in the coronagraphs at about 5 o'clock. We'll get to it. Is it earthly directed? Is it going to end civilization in a few days? Do you have your fingers crossed that it ends civilization in a few days, as so many commenters have? And let's talk stats. The 10.7 centimeter radial flux now all the way down to 137 solar flux units. And if you think we're headed back to solar minimum in the middle of a solar cycle, think again. That's like twice the radial flux that we see at solar minimum. There's a 1-year graph of the radial flux depicted by that black line there. The red line is the sunspot number. There it's being reported at about 58 sunspots. We'll get to sunspots here in a minute. First, check it out. NOAA is forecasting a geomagnetic storm tomorrow night, October 19th, into early morning, October 20th. So that is the fourth CME that we forecasted to be earthly directed. The first two have already shown up, and they've been weak impacts. No real surprise there to our regular viewers. We'll get to those here in a moment. But check it out. The latest of the one that we forecasted yesterday, in other words, NOAA agrees with that forecast. It is expected to arrive on Wednesday night. I mean Thursday night. Oh, yeah, what day is it? Wednesday night into Thursday morning is going to be the strongest of the CME impacts. Again, two of them have already shown up. We'll get to it here in a minute. Here's Earth's magnetic moment from space for the past 4 hours. And as you may have expected, an increase in the solar wind has increased the magnetohydrodynamic pressure. If you're watching our videos regularly, that shouldn't be a surprise to you at all. However, these are only minor increases so far. The past 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. Changes to Earth's B field, geospace delta B, depicted in magnetic flux density nanotesla. So a little bit of an uptick here in the aurora over the past about 12 hours, actually. So that's the past 4 hours of Earth's magnetic moment from the ground, our geospace ground magnetic perturbations map. KP is only at 1.33. It only ever made it up to 2. And again, the initial CME impacts did show up exactly as forecasted, and they were quite weak, along with very weak magnetic fields. We'll get to it here in the solar wind data. So check it out. Here's the active spacecraft which is showing as ACE and Discover. And the real measurement was by Discover. Oh, now we're back to the Discover for the active spacecraft. Oh, no, we're not. We're still with ACE and Discover here. It's claiming ACE and Discover are the active spacecraft. Anyway, here's the data from Discover. And here is the first CME impact. It showed up late in the day on October 17th, exactly as we forecasted. Solar wind density made it all the way up to the low 30s. 31.5 protons per cubic centimeter there. And you can see this mixed in with this really weak solar wind regime. You can also see changes in the plasma temperature. That is a sputtering CME impact, a series of filaments passing by the Discover. So perfect example of a CME impact. And look at how weak the field was. The field was at 1 nanotesla with a BZ of 0. So that is extremely weak field activity. Look at the plasma temperature down there, this bottom green line down here. So the CME was hotter, denser, and faster than the background solar wind regime. No real surprise there. And then it looks like a second impact striking right here. So early in the day on the 18th, that's CME number 2, accurately forecasted. And that looks like it was pretty short-lived, although this could be a series of outer shells and cores coming in. So sometimes you might see, in other words, the Discover might show up with another increase to levels like this. But that's clearly a second different solar wind regime once again, because look at its different plasma temperatures. So you see those variations in the plasma temperatures. Those are different solar wind regimes measured by the Discover. Facts. So, and by the way, the way to change the active spacecraft is to click on Series. You can pick Active Spacecraft, Discover, or the ACE. So that is what's been going on. 2 of the 4 CME impacts we've forecasted showed up right on time. Are you surprised? So, and you can see how vastly different they are. This one featured just weak magnetic fields. This one, variations in the magnetic fields and a much more consistent signal, as it has tapped out this extremely slow solar wind there, making it all the way down into the low 280s. So right now the Discover is showing 7 protons per cubic centimeter and 380 kilometers per second for the solar wind. And the ACE is showing extremely diffuse solar wind here at less than 1 proton per cubic centimeter and 351 kilometers per second for the solar wind speed. That is the active spacecraft, must be the ACE, because that's not what the Discover's showing. So anyway, that's how to look at the 2 different spacecraft there orbiting Lagrangian point 1. Those are located about 1 million miles away from Earth. So they have to be outside the magnetosphere to measure these weak fields and this diffuse plasma. From inside the magnetosphere, there's no signal there. So they're about 4 lunar distances away, orbiting Lagrangian point 1, the gravitational equilibrium point right in between Earth and Sun. Here are the GOES magnetometers for the past 3 days. And we are seeing some significant variations here. So this second CME impact is looking a little bit more effective in terms of affecting the geospace. So some plasma variations happening there, creating magnetic fields there as measured by the GOES magnetometer. The GOES magnetometer on the GOES 16 and GOES 18, those are located at a geosynchronous near equatorial orbit. They orbit at about 23,500 miles of altitude, way up there in the outer portion of the outer Van Allen belt. Next, top view ecliptic plane field plot. Earth is right in the center of a south pole current sheet. And check it out, we've got some predictive value here. Look at that. So it looks like there may be some sunspot growth or a new sunspot about to rise in the southern hemisphere because we see this acceleration of the North Pole current sheet. Watch. You're going to see this North Pole current sheet shown here in green suddenly speeding toward Earth. That is an indication of a new sunspot either rising or forming in the southern hemisphere. So there's a great example of some predictive value there in the Gong 2 data. We show it daily on the channel, and it's pretty tough to predict sunspots. If anybody's doing it, let us know in the comments who you think might be doing it. It's a matter of understanding the physics, how the data correlates, and knowing how to do it. Good luck to everybody else who's trying. Next, our line of sight field plot. And yeah, it's the solar B field, the Gong 2 magnetogram in grayscale, solar B field in blue, polar fields in green and red for north and south respectively. And interestingly enough, we do have some South Pole magnetism already starting to collect at the North Polar region, as seen here in the coronal hole line of sight plot. So that's a little bit early for coronal holes to be starting to stagnate at the North Polar region. You can also see quite a lot of North Pole magnetism there hanging out at the South Polar region. That's interesting. However, we are still expecting an uptick for the next 2 years in coronal holes because, statistically speaking, solar sunspot cycles are extremely consistent. The idea that this cycle is going to be extra short or extra long or anything like that is just silly. According to the fossil record, it's possible that the solar sunspot cycles have been very consistent, around 11 years, for like 700 million years. Were you aware of this? Yeah. Extremely consistent. That's probably why things like you exist. How do we know the sun's not electric? Well, one of the ways we know the sun's not electric is because you're not dead. Yeah, the fact that you're not dead. If the sun relied on a Birkeland current to keep itself in existence, you would be dead. There would be no life on Earth. It would be way too volatile. That's just a ridiculous, silly, and idiotic notion. The universe is not electric, and neither are stars. They're not made of gaseous plasmas in the first place. Anyway, here is coronal holes from SDO, 211 angstroms. And yeah, those coronal holes are South Pole oriented. If you look at the last image here, we do have some North Pole rotating in, but so this is South Pole, and then over here we've got some North Pole coronal holes just making their way in as the North Pole current sheet shows up a little earlier than you may have expected. So expect to see some growth or a new sunspot in the southeastern limb. Facts, predictive value, understand the physics, understand how the data correlates, and you too can forecast space weather, Earth weather, and probably even gold prices. Now that's getting into the weeds. All right, so check it out. Sunspot number, as we move to sunspots, is now below 70. It looks like about 69 sunspots there, according to Royal Observatory of Belgium. That's pretty low. So get in your bunkers. Oh no, it's a grand solar minimum. Oh, it's time to be spooked. And now that I got that out of my system, we still aren't at solar maximum. So don't expect this temporary lull in action to continue. And let's talk about the flare monitor and scoreboard. Likelihood of large flares is kind of low at the moment. In fact, we've seen the background level of X-ray flux drop into the B range. So at the moment, not very many sunspots and not very many likely spots for any kind of major changes happening. The most likely place to see a large flare, major sunspot growth, and sunspot evolution is right there at 3468. So that's what the Gong 2 data is telling us. There's a forecast based on understanding the physics. Moving to sunspots from SDO's perspective, there is the SDO. There is the SDO. The HMI instrument showing the continuum, and the AIA instrument showing 94 angstroms to highlight active regions. Largest flare was only a small C-class flare for the past 24 hours. Let's subtract 94 angstroms to show sunspots alone. And it looks like some formation of new sunspots right here around the equator in the eastern quadrant. Possibly 2 new groups, one of them kind of large right there. Maybe even 3 new groups. So there's a new pore opening, it looks like. There's a new pore, perhaps. A series of sunspots there. And again, don't be surprised to see this sunspot grow, or even a new sunspot to rise over the southeastern limb. So anyway, I call them like I see them. Don't like it? Leave an angry comment. We love angry comments. Goes proton flux here. No spikes. No spikes in the proton flux. And it's not really that likely to see a spike in the proton flux. Just keep in mind, again, you can have spikes in the proton flux without even seeing a solar flare, because a coronal mass ejection can cause a relativistic particle event. At the moment, flatlined here for an extended period of time. And the X-ray flux, again, like I said, it's back in the B level here. Only about a B5 background flux at the moment. So very weak solar activity here as we continue to ramp up to solar maximum. So now this long duration C-class flare was associated with a quite massive coronal mass ejection. We started out the video with it. You're probably wondering if it's earthly directed, as CMEs are currently arriving. So we'll get to that here in a moment. First, let's take a look at the SDO, and that's a 24-hour video with 94 and 131 angstroms. Now, that long duration C-class event, it came from back here behind the limb, I believe. So it could have been associated with a much larger solar flare. But that was obscured by the solar limb. Yeah, the surface of the sun was blocking that. Because stars have a real surface, not an illusory surface. If stars didn't have a real surface, how would we use helioseismology to see what's going on the opposite side of them? Waves don't propagate through plasma. You need a surface for seismology. So you need condensed matter. I'll just leave it at that. Next, we'll look at a star chart. This is what's going on overhead Lehigh Valley, Pennsylvania. The sun hasn't even risen yet. Skyandtelescope.org is where we get our star chart from. If you're up before dawn, you might see the 3rd brightest object, Venus. And sometimes the 4th brightest object, when it's not Mars, Jupiter, setting there on the northwestern ecliptic. So that's what's going on overhead. Here's what's going on in the solar system. Let's advance this 1 week. There's where things will be in a week. We'll have a gibbous waxing moon. And if you're wondering what those purple halos are, those are planets that are in retrograde. The outer planets are all in retrograde right now because Earth orbits more quickly than they do, so they're moving in the opposite direction from the background stars. That's literally all it means. Jupiter, Saturn, Uranus, and Neptune, they're all in retrograde. That's what the purple halo means. Absolutely nothing else. It has to do with planetary motions, and that's it. So, that's the current situation. And let's talk about the Veil Nebula. Since the Veil Nebula, located in the constellation Cygnus, where the real action is at in the Milky Way galaxy, the Veil Nebula is the astronomy picture of the day. if you want to read about it, feel free. Visible with the binoculars, it is a very dim nebula, again in the constellation Cygnus, right on the galactic disk. It is visible with binoculars. It's about 6 times the size of the full moon. Just not easy to see because it's kind of dim and diffuse. What's interesting about it is it's got all kinds of complex chemical elements in it, like hydrogen. Well, that's no surprise, I guess. But don't forget sulfur and oxygen, also present in the Veil Nebula. Anyway, here's an amazing image of it from, guess what, James Webb Space Telescope. Believed to have been produced about 15,000 years ago by an exploding star. And look at the resolution of those stars, just fantastic. A chemically complex soup of plasma filaments hanging out there. And remember, folks, the interstellar environment is nothing like the solar system. The interstellar environment is filamentary in nature. So while the solar system has this very predictable Parker solar spiral disk of plasma that's constantly coming out of the sun, interstellar space is nothing like that. It's filamentary. It's nothing like the solar system. There's a prime example of it. That is how it looks in the areas between stars. The galaxy and the solar system aren't really very similar in any way. Sure, the stars all orbit the galactic core, Sagittarius A star, but that's about where the similarities end, folks. These things are very far apart. And the plasma has a tendency to form into filaments because it organizes itself as it flies through space with very little acting upon it. It finds itself in filamentary string-like features, as you can see there in the Veil Nebula. And there's the star that is, I think it's in the foreground, actually. But anyway, that's the astronomy photo of the day. And let's move on to coronagraphs since we have another great CME to cover. And unfortunately, once again, George Mason University has been down for 5 days here. Make it 6. And here comes a CME from this morning. And it happens at about 5 o'clock. You'll see it on the C2 first. Wowzers. That's a good one. Is it a halo eruption? Yes. Is it earthly directed? I'll go through the process that I did myself to reach a conclusion. So here we've got a clear halo eruption this morning. So I've got the C2 on the left slightly ahead of the C3 on the right. So you'll see that popping off at about 5 o'clock this morning. Make it 3 o'clock this morning. And there you can clearly see plasma coming out around about 60% of the solar disk there. So you can see a halo over here. It is a partial halo eruption for sure. But is it earthly directed? Well, let's consult stereo A to see if that helps. Here we've got the raw coronagraph slightly ahead of the difference imagery. And there indeed you can see that partial halo from stereo A's coronagraph. Great image there on the difference imagery. But is it earthly directed? Here's the video we started out with Mercury moving into the C2 there. And let's zoom in a little bit closer to see if we see any plasma motions on the Earth side of the solar disk. So this did happen around the same time as we saw that C-class flare, which occurred right up here behind the northwestern limb. And that is why that CME is on the opposite side of the sun. So that is not directed toward Earth. There is a second smaller event that happens down here, which is barely even noticeable. That also is not earthly directed. That's off to the southeast. So, and this happens all the time, folks. We see multiple events happening around the same period of time as ripples propagate across the surface of the closest star. Another indication that it has a real surface and that it's made of condensed matter as opposed to gaseous plasma. So just another prime example of this. I mean, let's zoom in all the way here. And let's switch to filaments, since we've still got a lot of major ones on the Earth-facing solar disk. Oh, and before we do that, let's take a look at a great prominence that happened. Here's a cool prominence that happened earlier this morning. Around the same time, actually. I think these events were all connected. So let's break that out. That's pretty sweet. And this is our Twitch stream. You can see it at smashomash.com/smashteam as well. It's hosted on that page all day long. So there's a great coronal plasma loop there, popping off on the eastern limb. Again, those events are all related. If we move this forward just a little bit, you'll see this event happening down here as well. Another minor CME there, happening just a few hours after that series of events. A C-class flare up here, a series of coronal mass ejections, and then another event right there. Also, again, not likely to have any Earth-directed components. Anyway, moving to plasma filaments, there's the El Teide, Spain ground-based solar observatory. And we still have a lot of filaments. This one up here is looking like it is getting unstable. So that's something. The Eric Weinstein filament over here is moving into a setting mode now. And as we say daily, thanks to our new Twitter followers. Congratulations on realizing we have a Twitter account. We're as surprised about that. I guess I should be more surprised that you found the Twitter account than that you found the YouTube channel. As, hey, thanks to our new YouTube subscribers, by the way. Thanks to our new Twitter followers. As we go up to the high 480s and then drop back down to the low 480s every couple of days. Because of censorship. Facts, they're very controversial, so we can't have those propagating. And by the way, I'll say it again. Freedom of speech absolutely means freedom of reach. If you're in the town square and there are 1,000 people standing there listening to you, and you have a muzzle on your face so only the people in the front row can hear you, how is that not censorship? That's 100% censorship. Freedom of speech is absolutely freedom of reach. Are you kidding me? It's called fascism. Fascism. Anyway, there's the other view from El Teide, Spain. It shows prominences. And it does indeed look like there may be another active region there rising in the southeast. You can see a prominence there in the lower left. And before we get to bonus features, let's show the last couple of hours here from the GOES 16. Crown prominence there, still hanging out in the southern polar region. Yeah, crown prominence. That's a feature associated with solar maximum. Even though we aren't at solar maximum yet, you can expect to see more of those in the coming year plus. Because solar cycles are extremely consistent in their length. the likelihood of a significantly shorter or longer solar cycle is shockingly low, statistically speaking. So anyway, we'll be keeping an eye on this area over here and this sunspot. That is the past like 2.5 hours from the GOES 16 SUVI. And here come bonus features. Starting with satellite charging hazards. We ain't got none. It's smooth sailing for satellites at the moment. No high energy electrons building up inside of, no low energy electrons building up outside of satellites. GOES electron flux here remains quite low. No surprise there to our regular viewers, with multiple coronal mass ejection impacts arriving. Keep in mind this does get erroneous during geomagnetic storm conditions. The GOES 16 and GOES 18 measure the GOES electron flux using radiography at the F layer of the ionosphere. They're tens of thousands of miles above the F layer of the ionosphere. The F layer is at 300 kilometers of altitude. The GOES 16 and GOES 18 are at like 23,000 miles of altitude. There's the 1-year graph. You can see a small uptick in the electron flux there over the past couple of days. That's the 1-year chart. And here's the forecast model. It looks like NOAA would agree with us, expecting a downtick in the electron flux in the coming days. I agree 100% with that forecast. Again, with at least 2 more coronal mass ejections on the way to Earth. Here's the layer where it's measured. It's the F layer, which is at about 300 kilometers of altitude. There is the vibrational frequency. Megahertz, millions of vibrations per second. It's very diffuse gas up there, and it's mostly ionized, which is why it's called the ionosphere. As radiation from the sun blasts electrons off of the particles that are hanging out. We also show the anomalygram. There's the anomaly in megahertz from a 30-day median. And no major scintillation of the ionosphere has occurred yet, again because those CME impacts have been quite weak. But we are seeing less high-frequency anomalies than we've been seeing for the past week, because the solar wind is not as weak as it's been. That is the effect of coronal mass ejection impacts. Anyway, there's the latest image, 10:45 universal time for the ionogram and 10:45 universal time for the anomalygram. Next is the WAM, the whole atmosphere model nowcast, depicting total electron content and maximum usable radio frequency. That should help all of you radio and GPS operators out there. And next we've got the total electron content. Feel free to pause the video in this frame. It does show the altitudes of things like the Outer Van Allen Belt, GPS satellites, the International Space Station, and so on. Here's our total electron content forecast. I still say that's anomalous, or you could say, I think it's erroneous, actually. I think there's some problem with the data here. I don't know what's going on with the total electron content forecast, so let's move on to the total electron content anomaly from the 10-day average over North America. As this looks totally fine, it does not look jacked up like the total electron content forecast, and no major anomalies here showing up over North America. We're almost completed with the space weather section of this video. Here comes the final segment, the SDO continuum and the SDO magnetogram. So again, we may see some sunspots here forming around the equatorial region. I see some small pores possibly opening up there. Maybe as many as 3 new sunspots are forming right there. And again, there may be a new active region rising somewhere down here. So let's see if we see any magnetic fields peeking up over the horizon. Nope, not yet. Here's the full disk view. And it's time to move to meteorology. Yeah, you can forecast your weather. Did you know that? Yeah. If you understand physics, you can forecast the weather. If you believe in chemtrails, you can't. Because if you believe in chemtrails, you don't understand atmospheric physics or airplane tech. Aircraft tech. If you believe in chemtrails, you don't understand it. Those are not a thing. Chemtrails, not a thing. Let's take a look at the Earth's largest waves. We're going wave chasing here, folks. And indeed, these are the world's largest waves, occurring under 46-mile-per-hour winds. The seas are pretty calm here around the planet, overall. The Southern Ocean here is pretty inhospitable, though. 33.5 footers down there. But overall, pretty calm seas here at the moment. There are some significant perturbations happening up there in the northern Atlantic. But things are pretty chill. The sea is somewhat placid at the moment. Anyway, here come the jet streams of the eastern world. And there's an anticyclone over the South China Sea as high pressure has arrived. You see that? It's a clockwise rotating upper air mass in the northern hemisphere indicating an anticyclone. Kind of like Jupiter's red spot, only much, much, much weaker. Here are the surface winds of the eastern world. Here are the surface winds of the central world. Here are the jet streams of the central world. Jet streams of the west. Multiple anticyclones here in the Pacific and Atlantic Oceans. Strong winds off the coast of California. Strong winds in the north central Atlantic. Here are the surface winds of the western world. Next, check it out, our precipitation type map. And I noticed that there's a strong low here in southern Greenland, and check it out, it's snowing big time up there in Greenland. Southern Greenland there, getting kaplastered with snow. And let's briefly look at sea temperatures. So that's what's going on with sea temperatures. And let's move on to our clouds and fog maps. It's still mostly dark here in Lehigh Valley, PA. We've got frigid air blasting down from Canada into the Great Lakes region. Also a powerful low here, rapidly making its way across the Dakotas toward Iowa. Here's a view of that. Great view of that low pressure there. You can see that counterclockwise rotation. It's not chemtrails. It's not even contrails. It's not HARP. Man doesn't control large-scale weather patterns. Only tiny, tiny portions of the atmosphere can be controlled by things like cloud seeding. And by the way, HARP has nothing to do with the atmosphere. It affects the ionosphere, not the troposphere, hundreds of miles lower in altitude where all of your weather occurs. Next, our weather.gov map, and things are pretty chill here. There are some wind warnings there and some heat advisories for California. So let's scroll down here and show you the key. There's the key. Not a lot of weather warnings on the map. And let's show a couple of forecasts. So first, the temperature anomaly forecast in degrees Celsius. That is the 72-hour GFS model for temperature anomaly. Mostly high temperature anomalies for the next 3 days, especially west of the Rockies. And we'll also show pressure and precipitation for the same period and the same model, the 72-hour GFS model. That's what's up. Next, lightning. That's the past like 10 hours of lightning. And here's a real-time lightning map from lightningmaps.org. I highly recommend it. Blitzachtung.org. Shout out to blitzachtung.org. And to German speakers. German, the best language for curse words. Ich möchte ein Kartoffelsalat. That means I would like potato salad. Du bist ein Bleistiftspitzer. That means you are a pencil sharpener. All right, moving right along. 438 strikes per minute here for the sensors at lightningmaps.org. We'll close out with Doppler radar, clouds and fog and water vapor over the U.S. There's the full 50-state view. We like to focus on the lower 48 view to close out these videos. There is the clouds and fog scenario, a bunch of low clouds over the western Atlantic and the Gulf. And there is water vapor, which should clear things up if your Doppler is unclear. Once again, there is your Doppler. Here's the recap. As we bring your space weather and Earth weather together, there's shortwave radiation from the NASA Interactive Satellite Suite. And there is the GOES water vapor map. More CMEs on the way. More facts coming at you today. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And because I've believed too much nonsense on the internet about things like space, I'm headed back to the bunker because a bunch of people who don't understand physics have gotten me very, very spooked, pardon the sarcasm. I'm going back to the bunker again. All the stupid stuff I've heard encouraged me to climb in.